All right, let's get right into it. Today, we're not just solving a math problem, we're cracking a case. We're going to put on our detective hats and investigate an equation that looks like it's straight out of a Math Olympiad. It's time to examine the evidence.
And here it is. This is the mystery we need to solve. Yeah, I know, at first glance it looks like a total monster, right? You've got square roots nested inside other square roots. But just like any good detective story, the most important clues are usually hidden in plain sight. So, before we just start trying to solve this thing, we need to lay down the law. We need to establish the rules of the case. In the world of math, this is called finding the domain. Just think of it as setting the boundaries where our real solution has to live. Any answer we find outside these boundaries, well, that's just an imposter. So what exactly is a domain? Well, it's pretty simple, really. It's the set of all the possible values for x that actually make sense in our equation. You know, the ones that don't break any fundamental laws of math, like trying to take the square root of a negative number. This is our crime scene, and it's time to put up the yellow tape.
Okay, let's follow the clues. Clue number 1. X is equal to a square root, right? So we know it can't be a negative number. That means x has to be 0 or something bigger. Simple enough? Clue 2. If we look inside the equation, the stuff under the square roots has to follow the rules too. A little logic there tells us that x has to be less than or equal to 6. But then there's a deeper clue. When you really look at the structure of this thing, it reveals that x has to be less than the square root of 3. And that clue, wow, that really narrows down our search area.
So, after our initial investigation, this is what we've got. We now know with absolute certainty that our culprit x is hiding somewhere between 0 and the square root of 3, which, by the way, is about 1.732. This is a huge breakthrough for us. We've taken this infinite number line and shrunk it down to a tiny little neighborhood.
Okay, so we've taped off the crime scene. We know where our solution has to be. But, look at this equation. It's still a tangled mess. We could just try squaring both sides over and over, but that's a brute force approach and it gets really ugly really fast. We need to be smarter. We need a more elegant tactic.
You know, the best detectives, they know when to use a clever tactic. And in math, one of the best tactics is substitution. We're going to simplify this whole case by giving that really tricky inner part of the equation a brand new identity. Let's give it a disguise, and we'll call it y.
And here it is, our secret weapon. We're just going to say that y is equal to the square root of 3 plus x. This one little move is about to unravel the entire mystery. Seriously, just watch what happens next.
And boom, just like that, our one really complicated equation magically transforms into this beautiful, clean system of two much simpler equations. Now we have x squared equals 3 minus y, and y squared equals 3 plus x. Come on, that is so much easier to work with. The power of a good disguise.
All right, we have our simplified case file. We've got our two neat and tidy equations. Now for the fun part. It's time for the interrogation. We're going to make these two equations talk, and trust me, they are going to lead us straight to our suspects.
So here's how the interrogation goes down. First, we just subtract that second equation from the first one. You can see the 3's cancel out right away, which is nice. That leaves us with this. Next, we pull out a classic algebra move. We factor both sides of the equation. And after one little bit of rearranging, bam! We get our final critical clue. This whole expression has to equal 0.
Now think about that for a second. For that whole thing on the left to equal 0, one of two things must be true. Either that first chunk, the x plus y part, is 0, or the second chunk, the x minus y plus 1 part, is 0. This single insight breaks the case wide open, giving us two totally separate leads to follow.
And here they are, our two big leads. Lead number 1, x plus y equals 0. Lead number 2, x minus y plus 1 equals 0. We're going to have to investigate both of them to make sure we round up every single possible suspect.
Okay, so we follow each of these leads. It involves a bit more algebra, substituting y back in and solving a couple of equations. We won't bore you with all the number crunching, but when the dust settles, we end up with a grand total of 4 potential solutions. These are our suspects. And here they are. It's time for the official suspect lineup. We've got 4 possible values for x. They all came out of our investigation, so they all seem plausible at first. But we know from our earlier work that only one of them can be the real culprit. So this is it, the moment of truth. We have our lineup, 4 potential answers. But which one is the true x? How are we going to figure this out? We go back to the beginning.
Back to our crime scene boundaries. Remember that yellow tape we put up? We're going to test every single one of our suspects against that rule we established. Our real x must be between 0 and the square root of 3. Any suspect that's outside that zone is an imposter.
Let's check their alibis. Suspect A is about 2.3. Is that inside our boundary? Nope. Rejected. Suspect B is negative. Also outside the boundary. Rejected. Suspect C is -2. Way outside. Rejected. And that, well, that leaves only one suspect standing, the number 1. Does it fit within our boundaries? Yes, it does. Perfectly. And there we have it. After a thorough investigation, after following all the clues and checking all the alibis, we can confidently declare that the one and the only solution to this mystery is x equals 1. Case closed.
It's a pretty amazing feeling, isn't it? To take something that looked so complicated and just unravel it, step by step. It kind of reminds me of what the mathematician Stanislav Ulam once said. The charm of a beautiful problem is that it invites us to explore our own abilities. And I think that's exactly what we did here today.
This whole case just proves that even the most intimidating problems can hide these simple, really elegant solutions if you just know how to look at them in the right way. It really makes you wonder, doesn't it? What other beautiful, elegant truths are out there just waiting for us to uncover them? Thanks so much for joining the investigation.